7.2. Using function annotations. Function annotations allow us to associate arbitrary values with the parameters and return value of a function. We can access these annotations from program code by combining annotations with decorators or other code that accesses the annotation programmatically, and we're going to see how to combine annotations with decorators to alter Python semantics. In the last video, one of our examples was a decorator that automatically passed all of a decorated function's arguments through an adapter. That's pretty cool, but what if we wanted each parameter to be handled differently? Sure, we could pass a whole bunch of adapters into the wrapper, but that becomes ugly and clumsy as we start dealing with functions that accept more parameters. What we'd really like to do is attach metadata directly to a function's parameters. The metadata could then inform the decorator of what it should do. Fortunately, that's exactly what function annotations are. This example shows off Python's annotation syntax. To associate a value with a parameter, we put a colon after the parameter name, and then write an expression. That expression will be evaluated when the function is defined, and the result will be stored associated with the parameter name. We can also associate an annotation value with the return value of the function by writing a dash greater than arrow symbol after the function's parameter list, and then an expression which will be evaluated when the function is defined, and the result of which will be stored associated with the name return. All of the annotations are stored in a dictionary called _annotations, which is an attribute of the function itself. As we can see here, annotations are not type declarations, though they can certainly be used for that purpose, and they resemble the typing syntax used in some other languages. They are arbitrary expressions, which means that arbitrary values can be stored in the annotation dictionary. They don't have any meaning to Python itself, except that it should store the values, but they can have a great deal of meaning to our code. Annotations combine well with decorators, because annotation values make a good way to provide input to a decorator, and decorator-generated wrappers are a good place to put code that gives meaning to annotations. For example, let's rewrite that decorator from the previous video. We'll switch to using only keyword arguments, just to keep things relatively simple for the example. The adapted decorator encloses the function in a wrapper. That wrapper only accepts keyword arguments, which means that even if the original function could accept positional arguments, they would have to be specified by name once the wrapper has been applied. The wrapper also looks for adapters in the function's parameter annotations and applies them before passing the arguments into the real function. Once the function returns, the wrapper checks for the return value adapter and, if it finds one, applies it to the return value before finally returning. When we take a moment to consider the implications of what's happening here, it's pretty impressive. We've actually modified what it means to pass a parameter into a function, or to return a value. Let's take a look at another example. Sometimes one or more of a method's parameters don't require any processing except to assign them to an attribute of self. Can we use decorators and annotations to make that happen automatically? Of course we can. Let's say that if a parameter is annotated with a string, the value assigned to that parameter will be assigned to an attribute of self using the string as a name. And if the parameter is annotated with true, the attribute will have the same name as the parameter. If there's no annotation, or if it's not a string or true, nothing should happen. Again, for simplicity's sake, let's limit ourselves to keyword arguments. As we see here, annotations simplify all sorts of code-based manipulations of code. We're using basically the same techniques as the previous example, but we're doing something entirely different with them. We've been looking at decorators as the primary consumers of function annotations, but that's not necessarily the case. Any code that uses a function object might be written to benefit from annotations. That means anywhere we pass a function as a callback, we can potentially use function annotation data to make the code smarter about what it does with the function. Event handlers could be annotated with the names of the values the handlers want to receive. Dependency injection could be automated in a similar way. Constraint-based systems could be provided with the constraints that apply to each parameter. Probabilistic reasoning systems could be annotated with prior probability distributions. Parameters could be annotated with the proper user interface element to display in order to have the user input the parameter's value, and so on. The possibilities are seemingly endless. Before we wrap up this video, I'd like to point out one thing that may be helpful down the road. Our example decorators that worked with annotations were all limited to keyword arguments for simplicity. If you find yourself wanting to do similar things but needing to handle all sorts of parameters, the inspect module's signature function will simplify the process significantly. Annotation values are the result of arbitrary expressions that are evaluated when the function is defined. The _annotations attribute stores in a dictionary mapping parameter names and the word return, which is not a valid parameter name and therefore won't overlap with anything, to annotation values. The meanings of the annotations are entirely up to the code that processes them. Python itself doesn't do anything with them except to store them. Annotations combine well with decorators, where a decorator applies a wrapper that processes annotations. And that's it for the video on function annotations. Next, we're going to look at class decorators.